Hey guys, welcome back. This is the second part of Chapter 4, Section 1, where we're learning to name binary ionic compounds. That's a mouthful, so what does it mean? Binary means two, all right? Why two? Two because all of these compounds have a positive cation and a negative anion. And as you learned a long time ago, opposites attract each other. So that's precisely what's happening. It's binary because of the positive and negative piece, and then the electrical forces pull those together. Opposites attract, and that makes a very durable compound called an ionic compound, right? And so binary because there's two pieces, ionic because the two pieces have charges, and compound because it's, what were the three properties to be a compound from Chapter 1? It's got to have two or more elements. The properties of the compound have to be different from the properties of the elements that make it up. And this is embarrassing. I'm forgetting the third one. Nope, it's gone. Hey, man, look at that. Anyway, if you can come up with it, send me an email, let me know. And so we're naming type 2 compounds. In the previous section, we named type 1 compounds. So what's the difference? Well, that's what this is all about. The periodic table is divided up into this right side, right of the black stair-step line, and then the left side of the stair-step line. Everything to the right is going to be a non-metal, and we're going to ignore those for now and not pay any attention to them. In this section, we're still focusing on all of the metals to the left of the stair-step line. Now, the metals are divided up into two categories. There's the dark blue and the light blue, and here's the difference. All the dark blue metals are type 1 because they have constant oxidation number. All right, there's another $10 word. What's an oxidation number? It's charge. So for example, the alkali metals in the first column always make a charge of +1. They form +1 cations in the language of chemistry. In the second column, the alkaline earth metals always form +2 cations. Aluminum, zinc, and silver always form +3, +2, +1 cations. Those are all type 1. Now, technically, there is one other type 1 cation, and that's this guy right here. Ammonium always has a +1 charge, which means it's a type 1, but we're going to ignore that for now. It's got several atoms to it, and we're going to deal with just single atoms for the time being. Pardon me. Bueno, what are all these light blue ones? Well, the light blue ones are things like nickel and chromium and iron that can have different charges, different oxidation numbers. Or to put it a slightly different way, they have variable oxidation number, and so we have to write them in a different way. So again, in summary, type 1 is all the dark blue. They have constant or consistent oxidation number, charge. The type 2s are light blue. They have variable oxidation number, or charge. So how do we write that all down? Well, here's the, I don't know what you'd call it, the way that chemists all decided to write. First of all, you name the cation. So this is just the name of the metal. It's nickel, or it's cobalt, or it's gold, or it's silver. Pardon me, not silver. It'd be gold or platinum or something like that. Not silver, because silver is type 1. And then you've got parentheses. So anytime you've got a type 2 compound, you're always going to have the name of the metal, and then you're going to have parentheses, and you're going to put the charge or oxidation number in parentheses. Now, you're not going to write it as a number. You're going to write it as a Roman numeral. Excuse me. All right. Thank you. You're going to write it as a Roman number, so we'll have to take a look at those in a minute. The anion always ends in IDE, just like it did in the last section. Fluoride, chloride, oxide, and so forth. All right, let's take a look at the Roman numbers. Here's a whole bunch of them. You really only have to know about the first 5 or 6, maybe the first 8. Beyond that, they're not good. Let's just say the first 8 to be safe. You're never going to have any in the teens, certainly. I mean, atoms hardly have this many electrons, right? So they couldn't lose that many electrons. This kind of thing might pop up as an extra credit question, something like that. The only time you would have seen things like L or C or really two places. One is in Super Bowls. For some reason, use Roman numbers. And when you open books, quite often the date they were published on will be written in Roman numbers. Sometimes, if you see an old-fashioned building, the cornerstone will have the year that the building was built in Roman numbers. But that's a little old-fashioned. I don't know if we do that anymore. So here's how you actually write type 2 cations. This is not the ionic compound. This is only the cation part, the first part. This is only the blue and the yellow. So here's how you write the ion. It's just the symbol for iron, or the symbol for copper, the symbol for cobalt, and so forth. And then in the top right corner, you put the charge, or the oxidation number. Now here's how we'll be writing that out. Instead of a chemical symbol, we'll write the name. That's the blue part. So iron, copper, cobalt, tin. That's the blue part right here, name of the cation. Now this Roman number in parentheses matches with the oxidation number. That's the yellow part, right? Charge of the cation in Roman numbers in parentheses. Well, this is what it looks like. So 3 plus becomes a Roman number 3. 2 plus becomes a Roman number 2. Plus becomes a Roman number 1. 4 plus becomes a Roman number 4, and so on. So in principle, there's not much to it, right? All you're doing is writing down the name and then copying down this charge. You have to translate it in the Roman numbers, but you've got this chart right here to do that for you. And you probably knew it already, so there's not much there. This is what it looks like when you put the whole thing together. Now, this is starting with a chemical formula and ending with a name. And in fact, the name looks a bit off, and I'll talk about that in just a moment. But the process is pretty straightforward. The very first thing you do is split it right down the middle. Step number 1, split it right down the middle. Look at the left side. Sorry, from your point of view, look at the left side. Iron. Okay, now you go back to this periodic table. Iron's right in here. Iron is a light blue type 2 metal. All right, so we have to use all the rules now for type 2. It's got a +2 charge. And now you say, whoa, Cato, hold on. I see that +2 written there. But if all I did was split this in half, how do I know what the charge is? How do I know if it's +1 or +2 or +3 if it's not written right there for me? Because on the homework it isn't going to be. Well, here's what you've got to do. You've got to work backwards. You know you have 2. Right here, this number 2 tells us that we have 2 chlorines. Chlorine's right here, it's a halogen. These halogens always have a charge of minus. That's going back to chapter 3. You might have to review that. The halogens always have a charge of minus. Pardon me. So you know that there are 2 chlorines because of this number 2. You know that each chlorine has a charge of minus because the charges on the nonmetals are always the same, right? There aren't variable charges for nonmetals. So you go back to chapter 3 if you have to and you look it up. If you remember it, then you're lucky. Now, if there are 2 negative charges here, there have to be 2 positive charges here. These things have to add up to 0. The charges have to add to 0. So if you've got 2 negatives, you have to have 2 positives. Okay, so we know it's iron. We know it has to have 2 positives to cancel out these 2 negatives. So we translate that. Instead of writing iron, we write out the word iron. And instead of writing 2 plus, we translate that into Roman numbers inside parentheses. Now, here's where it gets a little odd. Years ago, people would write this as ferrous or ferric, or we don't do that anymore. You might run into some old-fashioned chemists that do, and if you go online, you can find people doing this, but that's sort of a deprecated model. It's something that's discouraged now. And so what you really ought to do is write this as iron 2 chloride. Unfortunately, I couldn't find a good picture online that did that. And so in class, we're going to go over some of these examples on your homework. But in principle, there's not much to this. Anytime you've got a formula, split it in half, look at the left side. Is it type 1 or is it type 2? If it's type 1, you use the rules, basically just name it. If it's type 2, you've got to name it, and then you've got to figure out the charge, and that's what we're going to practice. Naming, it's easy. We could teach 3rd graders to name it. Finding the charge has a couple of steps, right? You've got to be a little bit human to do those steps, and so this is what we'll practice in class, is finding the charge. Now, we can go the other way around, and it turns out going from a name not this kind of goofy ferrous name, but going from iron 2 chloride to a formula is really easy. And I'll show you how to do that in class as well.